Hi, this is again part of the OCT tutorial series, though doesn't involve that much OCT. Hopefully, it will in the future. But TCFAs are not vulnerable plaque, is the point of the talk. And the point here is to defend why inadequate angiogenesis leads to failed healing, and what is the theoretical and experimental basis for making this statement. So we've proposed that ACS is not caused by plaque rupture or erosion, but failure to contain the clot that occurs after these events occur. Um, and that the failure to contain the clot occurs due to lack of angiogenesis, which results in uh, no synthetic cells in the area capable of containing the clot. And it also suggests that traditional therapeutics and diagnostics will be of limited value in reducing ACS risk through this from this mechanism. And it's based on three papers really, but two papers. One JAMA Cardiology paper in 2019 and one circulation paper in 2019. I'm Mark Brezinski. Uh, Relevant to this talk, I've been doing it to OCT or plaque research since 1984. And the 2014 paper on long cores and the 2019 paper on failed healing and inadequate angiogenesis are going to be cores to this talk. So, again, I started doing research in plaque in 2014. My first publication was 2015. In the early 90s, was in trying to find something that would identify vulnerable plaque, and this is discussed in another talk. In so optical coherence tomography did not work in non-transparent tissue at the time I entered the area, and it couldn't. It was only imaging at 30, taking 30 seconds to do one image, but there are reasons why is discussed in another talk. It had potential. So back in this was done about 1994, and we thought on the top we imaged the first vulnerable plaque. It would, this would be later called a TCFA, but no, it became clear that TCFAs weren't vulnerable plaques, and this statement, or you can read about this from Greg Stone or Dr. Brunwald, but only 70% of TCFAs go on to ACS, so you can't really call them vulnerable plaque, and they're definitely not useful for plaque specific intervention. So, as of 2014, a lot was known. This is a great review that includes Vermani and Falk, obviously major players in the field. And we would come back to this review and several others to have understanding of some of what we saw, particularly related to clot dynamics and intimal cellularity. But it's a great review, and it was the state of the field in 2014. But if we take that review, there's four areas, paradigms in it that needed we feel needed to be overturned. First, failed plaque healing and not plaque eruption and erosion is the major cause of ACS. Uh, the inflammation is obviously critical to the development of atherosclerosis, but I'm unaware of strong evidence it's involved in ACS, the actual event. Um, Rapid plaque expansion from leaky angiogenic vessels occurs in the carotids in animals, but it's a uncommon mechanism of um, occlusion in coronaries. And we needed to look at plaques longitudinally and not in cross section, which seems relatively simple concept, but none of us really came up with it. We came up with it by accident, and this was the dumb luck. So I was asked to see a patient while I was at Geisinger um, in Pennsylvania, where my family is from. And while I was there, they asked me to look at some OCT films, but this case in particular, and I'm not going to go through the individual slides, it's done in another study, but it was a patient who was getting a stent placement for exertional angina, and they ended up getting clot formation and vessel occlusion substantially distal, more than 5 millimeters from the actual stent. And you can see it in this figure, and I'm going to show it quickly in a video, but the stent actually clipped at the edge a TCFA, but the TCFA was in close communication, or was close to a long necrotic cord that ran axially. And to this point, we had seen these back in the 1990s, that they tracked very long distances, but thought they were artistic and didn't make a connection. But what happened is blood rushed in, evacuated the core, and so in spite of the fact this patient was on antiplatelets and anticoagulated, they formed a clot distally. And what was interesting also was there was a second TCFA that was ruptured distally, but it had no long core, and there was no clot formation associated with that TCFA. And we can just see it quickly in this video. I'm trying to make my videos shorter. So plaque ruptures, drives out the necrotic core, and then clot forms and vessel occludes. So, we made this statement in Nature Reviews in Cardiology that the core evacuation, long cores were associated with ACS, but we proposed the mechanism core evacuation. And I believe it was in response to this, there's a response, I believe it was from the Mount Sinai and Washington groups, that said, well, we would see more core evacuations if that was true. And it still may be true. There's more complicated reasons, but it forced us to really rethink why long cores were causing ACS. So how are long cores causing ACS, or related to it? And, it's a higher statistical probability. The composition may be different. We did entertain failed healing. Blood may still be driving out more core. And so, but we needed to look at this. And so we looked at the literature, at how many, at studies that looked at plaques longitudinally, and we only found one. Now, very talented group. You've got Greg Stone, Vermani, Muller, among others. But they were looking for frequencies of TCFAs, were one of the objectives of their study. They were looking at frequency and distribution. So they cut off the edges of their sections, so that you couldn't really look at core length in their paper. So there was no prior paper. So we looked at histopathology of 150 samples longitudinally, and we were examining them, and honestly, there wasn't a hypothesis right at the moment. But we started looking at them in trichrome blue, and up until this point, angiogenesis was universally, since the 1980s, said to be radial. It came from the adventitia through the media into the intima, but we weren't seeing that. So if we look at the top trichrome, what we see is adventitia is toward the branch vessel. The lumen is obviously the top on this vessel. And the angiogenic vessels are going up near that branch vessel, and then they're writing along the top. They're not through the length, and the bottom green images are stained for von Willebrand's factor for endothelial cells. There aren't a lot of vessels as you go down this track in the media, so they're running along the length. And so this was somewhat shocking to us, and it came as a surprise. And again, I would like to say we postulated it, but it was just a matter of looking over and over again at slides. And then this slide really illustrates the point, and this was published in Circulation. So the necrotic core is seen NC on the top in trichrome blue, and and vessels are coming from left to right across the top. The core is more than 8 millimeters in length, and we're focusing on sections B and C. So in B2, we change it to grayscale, and von Willebrand staining vessels are shown by white areas, and we put arrows next to them. And the area B has a lot of vessels and a lot of cellularity. If we look at area C, there's several things. One, the necrotic core is right at the surface. This may or may not make the criteria for a TCFA. And the second thing was the vessels just weren't getting there. Between B and C, the vessels stopped, and then there was no cellularity. So the vessels, if we look at D, the vessels can't get around in cross section. They need to cross over the top, and if they can't reach that area, synthetic repair mechanisms, cells that repair the intima, don't have a blood supply, and so you lose those cells. And you look, and if we just look at this one at the bottom in E, this one plaque, this is 40 millimeters long, stretching from the left main down the LAD, and the OCT images show it doesn't stay in one plane, but this is a challenge to maintain vasculature because the blood vessels won't go through the necrotic core. So how is ACS related to failed angiogenesis was our next question. And why were we seeing something that was a complete paradigm shift? Till this point, angiogenesis was bad. Anything you read, and I'll show you example papers. So our own histology, we're going to go back to the original studies in the 1980s from the Berger-Silverman group. We did OCT imaging with injecting contrast. Looking at patients who received angiogenesis inhibitors. In the Prospect trial, I'm not going to talk about that here to try to keep it short, but they saw plaques rehealed, and we were seeing areas where new vessel growth was occurring. So TCFAs were going from thin cap back to thick caps again. And it's a similar mechanism to what we're going to be dealing with. New vessel vasculature was growing in. And unfortunately, so the Prospect study was an IVUS study. Unfortunately, the only thing we got from OCT studies were confirming ACS and lung cores were associated. It didn't tell us anything about healing, contrary to what some people have said recently. No, it wasn't part of our logic. So these are examples of 4 papers. When we look through the papers, if you looked in the tables, so after our 2014 paper, you started to notice people were putting in their tables the length of cores. And 2 of these papers don't relate to, quote, healing. But the top 2, it's talked about in the PS-OCT lecture, why we question, are they measuring healing or not? But if you look at these 2 papers by some of the same authors in the same calendar year, one seems to say that when you see healing, these patients need to be treated more aggressively, and the other one seems to say that when you see a lot of healing, then the patients don't need to be treated aggressively. But irrespective of it, in both papers, the group that had ACS had much more severe atherosclerosis by angiography. So that is mechanistically the clear mechanism. Whether or not they were actually measuring healing, I don't know. I have issues with it. But this paper, on the other hand, was an important paper. And this was the Mann and Davies paper back from 1999. And they said that clots, TCFAs, rupture, or plaque erosions occur at clot forms, and then the majority of times it's contained. And so this was an important part of our thinking. So failure to contain was seemed like a mechanism uh, for ACS, failure to contain the clot, the ones that don't heal. And this was sort of the core of the basis of the logic. But it's we had to go back and to look at some of the older data, and uh, and to be fair, we spotted this in the 2014 review with Vermani and Falk. One was that uh, clots, if you rupture, you just don't get a clot formation that occludes the vessel. It can take days to weeks before you get the onset of symptoms. And this was very important because if it occurred instantaneously, then there's no way you can get healing cells into the clot to contain it. And so this paper was done by JAMA in Circulation in 2005. And then the Gary paper was also very important, that they saw that, between 2 and 7 days, you got endothelial cells and actin-negative smooth muscle cells getting into the clot and containing it. And there are two related papers below it. And so now, mechanistically, if you don't have the synthetic cells, if the area has poor healing, it seemed logical that that the clot would just get out of control and occlude the vessel. So angiogenesis was universally believed to this point to be destabilizing plaque. And so where did this come from? And the Vermani paper, this is from the New England Journal of Medicine in 2003, discussed this plaque hemorrhage. So, and I believe they're correct with that. When the vessels get into the core, they are a major source of cholesterol. There's red blood cell walls, but I don't believe the evidence supports it causes rapid plaque expansion, and the fact that these angiogenic vessels, are leaky, further support that they contribute to cholesterol and lipids to the plaque, but not rapid plaque expansion. And this is a review as of 2017, which still held this view. And every drawing we had seen up until this point showed axial movement of the blood vessels. They went from adventitia through the media to the intima, and this isn't what we were seeing. So we went back. Where did this concept come from of radial or axial blood supply? And it started with the Berger paper in the New England Journal of Medicine in 1984. And in fairness, their first paper was just trying to show blood supply to the intima came from the adventitia, not from the lumen. And it sort of got blown out of proportion, that it got extended into rapid plaque expansion. But in their paper, they said they only showed still images, and they had looked at injected silicone in vessels that were dissolved and watched the flow into the vessels. And they said video would be available, but we couldn't get a hold of the video at all. But fortunately, in the third paper in particular, they published the data. And this is from that third paper. And A is adventitia, and it's the individual patients, which was critical in our analysis. A is adventitia, M is media, I is intima. So if you just look at the averages for the adventitia and the intima, yeah, they're the same. But when you pair the data, you get a completely different story. So first, and this is from our circulation paper, but it was an analysis of their work. So the number of vessels in the media, and you saw that in here, the number of the vessels in the media, which they didn't seem to comment on, was low, and they didn't explain that. And it was highly statistically different. angiogenesis in the media was rare. But to the right, what was more significant was the correlation between vessels in the adventitia and vessels in the intima on the right was poor. It wasn't, there was no correlation. So it was consistent with what we were seeing. At the ends of the long necrotic core, you have lots of adventitial vessels, and then the vessels go over the top of the necrotic core. So with where the necrotic core is, and there isn't a lot of adventitia, but now you have vessels over the top stretching these long distances over long necrotic core. Well, is there any in vivo data to support this? So yeah, I'm going to use angiogenesis inhibitors and thrombosis. So if you look at the studies where they used angiogenesis inhibitors in patients, clot formation and thrombosis, and including acute coronary events, increased, not decreased, with angiogenesis inhibitors. So this is completely in contrast with the paradigm at the time. And finally, is it due to, we're claiming it's due to tissue factors, not systemic factors. And is there support for it? And yeah, papers, the loads of papers that say, you'll see multiple ruptured TCFAs in a patient, including our paper, but you have one vessel that's the culprit vessel, which suggests it's a local factor. So again, this goes back to the JAMA Cardiology and Circulation papers, and you get the concept. So it leads to poor healing, angiogenic vessels not being able to get over the long cores. So long cores and poor angiogenesis are lead to vulnerability and the loss of cellularity there. And so if you've got a region that has no cellularity, and the core erodes the intima, so you have no synthetic capability, but the necrotic core will erode intima, will traditional therapeutics work in those areas? It's not likely, and I believe this is mentioned in that 2014 review. So these areas are at risk for rupture. They're high-risk areas, and current therapeutics aren't likely to work. Just reducing the lipid in the plaque is not likely to reverse this process. You need to get blood vessels into that area and increase cellular viability. And currently, conventional OCT can see the long cores, but it won't see poor healing, just traditional OCT. And we're looking at PS-OCT and OCT elastography as examples. And thank you very much. I appreciate the funding by the National Institute of Health, and thank you.